So last week we started talking about dilutions, and this is one of the more in-depth examples here. So we have a sample that's being diluted with 12 milliliters of urine and 36 milliliters of sterile water. After being diluted, the sample is tested and the reading is 213 milligrams per deciliter. What is the true level of the urine? Well, the first thing we need to figure out is what dilution was used. We have here 12 milliliters of urine. So that's 12 milliliters of concentrate in 36 milliliters of that NS, that's sterile water. However, remember, dilution is concentrate to total solution. So we will use the 12 milliliters for the concentrate, the urine, but the 36 milliliters of water is not the total solution. We have to add that to the 12 milliliters of the urine. So our ratio for our dilution is the 12 milliliters to 48 milliliters total. The milliliters do cancel out. Both of those will divide by 12 to reduce to a 1 in 4 dilution. Now, the reason we needed that dilution figured out is that dilution now tells us how to convert that reading. So if we have a 1 in 4 dilution, the 213 milligrams per deciliter is going to be smaller than the actual reading because that's the diluted reading. So that's going to go with the 1 up here. So to get our true reading, we can cross multiply and divide. 4 times 213 divided by 1, which is going to give us 852 milligrams per deciliter. Any questions on that? Okay, so just some quick reviews of last week's, the dilutions. Some little pieces. Let's say how much NS is needed to create a 2 in 7 dilution with 40 milliliters of serum. So remember, 2 in 7 dilution, the 2 is the serum, or the concentrate. The 7, however, represents what? Total solution. We know the amount of serum is the 40 milliliters, but we're not looking for the total solution. We are looking for the amount of normal saline, that neutral solution. We could just cross multiply and divide right here, get this number, and then do some subtracting. But let's convert our ratio here. We're going to do it to serum to NS. We're still going to have 2 parts serum. How many parts of that normal saline are we going to have? 5. Good. If it's 7 total parts, and 2 of those parts are serum, 7 minus 2 makes 5 parts that must be water. So now we put in 40 milliliters for the serum on the other side of the proportion, and we cross multiply. 5 times 40 divided by 2 is 100 milliliters. So it would require 100 milliliters of water. Let's see, how much serum is required to create 240 milliliters of a 3-in-8 dilution. So again, I'm going to write out the 3-in-8, the dilution, and I'm going to label it. The 3 represents the parts of serum. The 8 represents total solution, total parts. Looking at what we're given here, 240 milliliters is describing total solution. Are we asked to find the amount of serum? Yes, we are. So in this case, we are just going to cross multiply and divide. 3 times 240 divided by 80 is 90 milliliters. So we use 90 milliliters of serum to create that solution. Similar to the one we just did, what dilution is created with 50 milliliters of serum and 250 milliliters of saline? Remember, in our dilution, of course, that ratio is going to be serum to total. So we need to put in serum, of course, we have 50 milliliters. How do we find the total? There we go. Perfect. Add them together. 250 plus 50. So it's 50 milliliters over 300 milliliters. Milliliters cancel, both divide by 50. Gives 1 in 6 dilution. Or we're going to have how much of a 3-in-11 dilution can be created using 400 milliliters of normal saline. I'm going to try that one in your notes quick, and we'll talk about it in just a few seconds. Okay, so I always write down the dilution ratio first, just because I like to be methodical about things. So that 3 and 11 dilution, and I'm uptight about labeling things. So the 3 is the serum, the 11 is the total solution. Looking at it, however, we don't have either one of those. What we are given is 400 milliliters of saline. Are we asked, so the next thing we need to do is we need to ask, what is it that we're asked to find here? How much of that dilution? So we're asked to find the total solution. So what we really need here is a ratio that shows saline to total. So the total is going to stay the same, the 11. How much saline is there? How many parts saline? 8. Very good. So we kept the total solution of 11 parts. And of those 11 parts, 3 parts were serum. So the other 8 parts, 11 minus 3, must be saline. Now we can set up our ratio. The 400 milliliters of saline goes with the 8. And we'll cross multiply and divide. 11 times 400 divided by 8 is 550 milliliters. So the final simpler example I want to give you here before we move on, how much NS and how much serum are needed to create (360 milliliters of a 1 in 8 dilution. Okay, well, again, we have the 1 in 8 dilution. The 8 represents serum, or sorry, the 1 represents serum, the 8 represents total. We have the 360, which represents the total. And the serum is one of the things we're looking for. So let's go ahead and cross multiply and divide. 1 times 360 is 360. Divided by 8 is 45 milliliters. So it would be 45 milliliters of serum. To find the amount of saline here, there's 2 ways we can go. One way is we could just take the total 360 and minus the 45 milliliters. It's going to give us 315 milliliters. And if I were in a hurry, that's the way I would do it. But for right now, let's do this in such a way that we can double check it. So what I'm going to do is I'm going to create the ratio of saline to total, which is just going to be 7 to 8. Because if out of the 8 parts, if 1 is serum, the other 7 are saline. And put in my 360 total here. And when I cross multiply and divide, 7 times 360 divided by 8, I do get 315 milliliters. So 315 milliliters of saline does work. In cases like that where I can do it 2 ways, I do, just to make sure I get the same answer both ways. Okay, enough of the simple examples. Let's move back up to those more difficult problems, like the first one we did here at the beginning of class. Let's say that, again, we're looking at a blood sample that exceeds the meter. So it's too high to be read on the meter. Bless you. So we will dilute 200 microliters of blood in a 2-in-5 dilution. After the dilution, the meter reads 390 milligrams per deciliter. So a couple of things we need to find here. One, find the amount of sterile water that has to be used. And two, find the true reading. So looking at this, first part, find the amount of NS. Well, we have a 2-in-5 dilution. The 2, of course, is the serum, in this case the blood. And the 5 is the total solution. What ratio are we going to use to find the amount of water, of NS needed? Well, 3 to 5 would give us the NS to total, but do we know the total? We know the amount of blood. So for our purposes, it's going to be easiest if we have something that relates blood to the saline. What's that ratio going to be? 2 to 3. Good. 2 parts blood, that doesn't change. 5 minus 2 gives us 3 parts saline. And if we're going to use 200 microliters of blood, we can cross multiply and divide. That's going to give us 300 microliters of saline that's going to get mixed with it. So next, how do we find the true level in the blood from that 390 milligrams per deciliter that our meter reads? Well, we have a 2-in-5 dilution. What are we going to do with that? Perfect. The 390 milligrams per deciliter goes on top because that's going to be the diluted reading is going to be smaller than the actual reading. And you're correct. We're going to cross multiply and divide. 5 times 390 divided by 2. 975 milligrams per deciliter. So I want you guys to try one of these on your own. And here's what we're going to do. So we're going to assume that the blood sample exceeds the meter. We are going to dilute 20 milligrams of blood with 50, I should put, now the milligrams is right, with 50 milligrams of NS. After being diluted The meter reads 260 milligrams per deciliter. Find the true level. So I'm going to give you guys a couple minutes to try that in your notes, and we'll talk about it in just a couple minutes. Okay, so what's the first step we need to do here? Find the dilution. Very good. And what's that dilution going to be? How do we find it, I should say? Yeah. It'd probably be easiest to do them right away, to do 20 milligrams on top and then 50 over 20 on bottom, so that we do have the blood and the total. Or you could have done, the 20 over 50, got the NS, and then adjusted the ratio. That would work as well. So that gives us 20 over 70, or a 2 and 7 dilution. What are we going to do with that? Perfect. The 260 goes on top. And we cross multiply and divide. 7 times 260 divided by 2, which I believe is 910. Yeah. So the true reading is 910. So in what you mentioned there, that's something that we should look at just very quickly here. If we have a 1 in 8 dilution, what is ratio of serum to saline? It's going to be 1 to 7. There we go. Everybody's kind of tired this morning. What is the ratio of saline to total solution? There you go. 7 to 8. Perfect. So we should be able to look at that and see that dilution ratio of 1 in 8, and see both of these other ratios of serum to saline of 1 to 7, saline to total of 7 to 8. Because depending on the problem, all three of those ratios could come into play. Or I could just give you the dilution and ask for one of the other ratios too. I'm leaving that option open on the test. Okay, so what are all these dilutions used for? Well, let's look at the next place. Let's say that we have a 24% solution. So this is not a pure substance anymore. This is just it's a concentrate. And let's say we have let's go 250 milliliters of that solution. We are going to add 500 milliliters of saline. Find the new concentration. Well, if you recall from last unit, we talked quite a bit about these concentrations in solutions. And what we had was the amount of the active ingredient, the serum basically, is equal to the concentration times the volume. So now here we started out with 24%, 0.24, and we're going to multiply that by 250 milliliters. So the amount, bless you, the amount of active ingredient there is 60 milliliters. When I add that 500 milliliters of saline, have I changed the amount of active ingredient? No. So this is like going back to one of those mixture problems we did, only it's one of the simpler ones because what we're adding is 0%. So we're not adding any active ingredient, we're just adding total volume. So what we have here is we still have 60 milliliters of that ingredient. We don't know our concentration anymore, but our total volume has gone from 250 up to 250 plus another 500 milliliters. I'm going to drop the units. I'm going to drop the milliliters here. So 60 is going to equal our concentration times 750 milliliters of total volume. So we can find our new concentration here by dividing by the 750 milliliters. 60 divided by 750 is going to give us 0.08. So in other words, that's 8%. So we have diluted that down to 8%. If we look at this, what dilution was involved? Well, we started out with 250 milliliters of a concentrate. That's not pure serum, but that is the concentrate. We ended up with a total volume of 750 milliliters. That was the 250 plus the 500. And if we simplify that, that's a 1 in 3 dilution. So if we work on these in terms of that dilution, let's say that we have 120 milliliters of 64% solution. And we perform a 3 in 8 dilution. Find the new concentration. So once again, we're going to have to find our total active ingredient here, or serum in other words, and that's going to be the concentration of the original solution times its volume. 0.64 times 120. Which is a 76.8 milliliters of that active ingredient. So in this case, the dilution, the 3 in 8 dilution, is helping us figure out what our new total volume is. The 3 in 8 dilution, the 3 represents the concentrate. In other words, the 64%. And the 8 is going to represent the new total. So if we started out with 120 milliliters, cross multiply and divide, 8 times 120, I should have put milliliters in there. 8 times 120 divided by 3, we're now going to have 320 milliliters of that solution. So we can roll back here, back to our formula. We have 76.8 milliliters of that active ingredient yet. Our concentrations, what we're trying to find, our new total volume is 320 milliliters. So we solve for the concentration by, again, dividing by 320. So 76.8 divided by 320 should give us 0.24, and it does. So 0.24 equals X, so that new solution is now diluted to 24%. So this is just another way of doing those mixture problems that we did at the end of last unit, but only works when we're using pure saline, so no active ingredient in what we're diluting it with. Now, something we will notice if we go back through these problems. This one up here was a 1 in 3 dilution. The concentration went from 24% to 8%. Down here, it's a little trickier to know. Let me write this down. 1 in 3 dilution. Reduced our solution from 24% to 8%. This relationship here is going to be a little tougher to see. This was a 3 in 8 dilution, and it took our concentration from 64% to 24%. This one has a definite relationship. Both of these have a definite relationship between the dilution and the percents. The dilution, 1 in 3, is equal to the diluted concentration over the initial concentration, or the more concentrated level. So the diluted concentration after the dilution was 8%. Before was the 24%. And you can see I can reduce that down, 8 over 24, to 1 in 3. So probably the simpler way of looking at this, rather than using the technical terms diluted and initial or concentrated, the top one here is the after the dilution. The bottom one is the before the dilution. If we look over here, it's a little less obvious because the numbers are a little uglier, but that relationship is the same. We have that 3 in 8 dilution. On the other side, if I put 24% over 64%, 24 and 64 both divide by 8. That would be 3 in 8. So let's say we have let's see here, 360 milliliters of a 54% solution. We dilute it to 900, I don't know why I put 360% there. That should be 360 milliliters. We have 360 milliliters of a 54% solution. We dilute it to 900 milliliters. find the new concentration. So we need to find our dilution here. The dilution is going to be the concentrated volume over the total volume, or the final volume. So that's the 360 milliliters over 900 milliliters. The milliliters cancel out. What can both of those be reduced by? I'll start out with 10. Both of them end in 0, so I can divide by 10. That's going to give me 36 over 90. Am I done? No, what can they both still be reduced by? 3. Give me 12 over 30. Maybe divided by 3 again. Give me 4 over 10. And yes, 2 again gives me a 2 and 5. This is a 2 and 5 dilution. So that means we can find our new concentration. Got 2 and 5. What's going to go over on the other side here? You got the 54%. Is that going to go top or bottom? Well, that is the before. That has to go on bottom. Very good. Now, the other way to remember that is after we dilute it, that concentration is going to get smaller, so the new number is going to be smaller. So this has to go with the larger number in the dilution. So the 54% has to go down here. And we will cross multiply and divide. 2 times 54 divided by 5 is going to be, what, 21.6%, I believe. So our new solution, our new concentration is 21.6%. We don't have to know volumes here. We might just be told that a 32% solution is used in a 1 in 8 dilution. Find the new concentration. Well, here we know that we have a 1 in 8 dilution. Is that 32% going to have to go on top or bottom? Bottom. That's the larger number. After we dilute it, the percent's going to get smaller. So we cross multiply and divide. 1 times 32 is 32. Divided by 8 is 4%. So the new concentration is going to be 4%. We might look at what dilution is needed to dilute a 72% solution to 18%. So we are looking for a dilution here. On the other side, we have our concentrations. Which concentration goes on top, the 18 or the 72? 18% is the after, and it's also the smallest one. And on bottom, we're going to put 72. Now there's we don't have either one of the numbers on the left side over here to cross multiply or divide. And that's okay. All we really have to do is reduce this ratio. So we can cancel out the percents. Both 18 and 72 can be divided by 12 won't go into it, but 6 will. 18 divided by 6 is 3. 72 divided by 6 is 12. And those can still be divided by 3. So that's 1 in 4. So the dilution, it would be a 1 in 4 dilution. So now with this in mind, there are some pretty intense calculations we can do with it. We could ask how much let me get my numbers straight here. How much 24% solution is created by diluting 200 milliliters of 64% solution. So looking at this, we could look at the dilution created. Finding that dilution. Again, it's just going to be a matter of reducing this ratio. So what percent's going on top? 24 over 64. Now we reduce, percents divide out. Both of those can divide by 8. 24 divided by 8 is 3. 64 divided by 8 is 8. So this is a 3 in 8 dilution. Well, how does that help us? Well, remember that 3 was the parts or the amount of concentrate, and the 8 is going to be the total after the dilution, the total solution. So the 3 corresponds to the 200 milliliters. The 8 is going to correspond to the volume of our new solution. So I'll cross multiply. 8 times 200 divided by 3 is 533 1/3 milliliters. Any questions so far? So let's have you guys try one similar to that. How much of a 16% solution is created by diluting 240 milliliters of a 36% solution? Have you tried that one in your notes? And we'll talk about it here in just a minute or two. So let's take a quick peek here. So we have 16% solution and 36% solution. Trying to figure out what that dilution would be. Reducing that 36 over 16 over 36. Both of those numbers can be divided by 4, which would give me 4 to 9. So this is a 4 in 9 dilution. So we're going to take that 4 and 9. We have 240 milliliters of the concentrated stuff. That's the smaller volume. After we dilute it, the volume is going to be larger. So that 240 has to go on top. So it's going to be 240 times 9 divided by 4, which is, I believe, 540 milliliters. How many of you had 540 milliliters? Any questions on how I got there? Okay, it is time for a break. So let's go ahead and take our break, and we'll come back and we'll pick her back up.